Please welcome Developer Advocate from Google, Fred.
こんにちは. Today's talk is about architecting GWT or GWT applications for production at Google. There's two main topics that I want to talk to you about today. One is, of course, how we architect our applications, and this GWT plus RU thing, how is it actually working? If you like this talk, I think you'll really like this other one from last year, from Ray Ryan at Google I/O. It's about the best architecture practices. And if you've watched this talk already, there are two key takeaways that we'll build on further today. The first was that when you're building GWT applications, the Model View Presenter, or MVP, architecture makes a lot of sense. It enables you to do test-driven development and have all of your code be very easily testable. This architecture is also more easily understood or more straightforward than MVC, Model View Controller, which you may be familiar with. The other takeaway was that we should remove a lot of the interdependencies in our application. At the beginning of that talk, we started with this spaghetti diagram where every piece of code in our project was connected with many other pieces. This causes a lot of bugs and makes it very difficult to make any changes. Throughout that talk, we took this spaghetti and we pulled it apart and we created a lot more isolation or separation. And we used something called the event bus to route events to different parts of the system without all the interconnectedness. So those were the takeaways, and I really encourage you to watch that talk because it really builds the foundation for how we build our own applications at Google. Now, I want to talk to you about what production ready means. What does it mean to build production apps at Google? Well, it means that your applications are well tested, that you have lots of unit tests, and that when you make a code change, you quickly detect if you've broken any features. It means that your application is secure from other users, from malicious users. It means that you're able to monitor the usage of your application. You know what's broken, or you know why an application is slow, or a particular feature is slow. It means being scalable on two different dimensions. Obviously, you want to handle a lot of users for very successful applications. But scalability is also about handling lots of developers. When you have a complex project, multiple developers need to work on that same project without stepping on top of each other's toes. So you need isolation and separation so that a feature that I'm working on doesn't interfere and create bugs for a feature that my colleague is working on. Now, even though this is an AJAX application, we want it to be bookmark friendly. And that really means two things. We want simple URLs that encode state so that we can press the bookmark button and later come back to this URL. Or we can copy the URL and put it in an email and send it to a colleague so that they can get into the application with the same state. That's called bookmarkability. The second part is that the browser back button and forward button work. You'll see this in, for example, Gmail, that if you go to your inbox and then you click on a message, and that message opens up. When you click on the back button, you go back to the inbox. That's kind of what you expect. But you'll notice that the URL doesn't change. At least the main part of the URL doesn't change. The part after the hash sign is the only part that changes, the AJAX part. In order to enable the back button and the forward button and bookmarkability, you need to enable history support in the browser. And of course, production ready also means being able to support other languages, other regions, other settings. So we'll have three things that we're going to talk about today. The first one, which I'll spend most of my time on, is isolation. And that takes care of many of these items. Towards the end, I also want to talk briefly about instrumentation and suspicion. And that involves security. Now, localization has already been discussed in a separate session called GWT's UI Overhaul. And I encourage you to watch that. That's a very in-depth topic, so I won't cover it here today. So let's begin and talk about isolation. Remember the MVP model, Model View Presenter? Last year's I/O session talks a lot about it. This is another session that I really encourage you to watch. It's from Daniel Donalados, and he has done a tremendous amount of work in writing testable production applications at Google. He has some excellent tips and explanations, and you should really watch this talk. So Model View Presenter. The model is, of course, represented by DTOs, data transfer objects. These are similar to Java beans. They just have a few properties, very simple containers for entities. Now, if you implement what we've been talking about, then on the left-hand side, you have the client, and on the right-hand side, you have the server. The data transfer objects, or DTOs, transfer over the wire, over the network, via XML HTTP request, XHR. What the problem is, though, is that on the server side, you have domain objects, which are the real entities that you care about. These are the things that you persist to the database, like an employee record. And then you also have a very lightweight object, the DTO, which needs to be transferred to the client. So there's some duplication there. The employee is represented in two different classes. This is a lot of boilerplate to deal with, and it violates the principle of DRY. Do not repeat yourself. Do not write the same code twice. Do it only once. So our solution here is to handle the repetition using tools. In this case, you see the DTO class has a little gear sign on it. This indicates a class that we generate automatically for you, that you don't have to maintain. You just worry about the domain object, and we generate the lightweight version of that class. On the server side, we have the request factory servlet, which takes care of marshalling or transposing one object into the other. So let's look at this. We have a CRUD application. CRUD means create, read, update, delete. Let's first look at the simple case of reading or fetching data. Let's suppose we have an application and we would like to grab some data from the server, a list of employees, and pull it back down to the client for display. So what happens? We start with the presenter. That's where all our business logic is. That's where the engine is of our UI. Now you see here, there is something called an employee request. This is an automatically generated class. And many of these classes will be generated for you for the different types of queries that you might do. For example, query by first name or query by ID. The request factory is also generated automatically for you. This class knows how to do some basic caching, and it knows how to communicate with the request factory servlet. The employee record, which you see here, is the DTO. It's the data transfer object. It's also automatically generated. So you write the code in the presenter, and you write some code server-side, and we do the rest for you. So how does this work? The presenter creates a new employee request object, and it sends it to the request factory and says, give me the next 10 employee records. The request factory uses the JSON format to send this request object to the servlet. The request factory servlet, which is a standard servlet that's different than GWT RPC, it handles that request and it ships the results back to the client, again via JSON. That result comes back in the form of multiple employee records, or DTOs. Since it's JSON, it can be evaluated on the client in JavaScript and instantly turned into objects. Then the presenter can take the resulted data and display the results in widgets, instantiate the view. So let's look at something a little more complicated. Let's look at the write case. So update, delete, and create. So again, we start in the client with the presenter, but we have a new object called sync request. These sync requests can handle many types of use cases. The sync request will make sure that the view, the changes that are made on the client, are transferred to the server. So we create one of these sync requests for an employee record. Let's say we've changed the first name property of an employee. We send it to the request factory, which sends it via JSON to the servlet. But along the way, the servlet then sends the result back via JSON. This result might be success or not good. If it's not good, then only the caller is notified. Only the presenter will receive an answer that says, sorry, your update failed. And then nothing else happens. And the presenter can handle the error and maybe try again or display the error to the user. In the case of success, the result comes back from the servlet to the request factory, and automatically a new event is generated, an employee changed event. This code is also automatically generated, and this event is sent to the event bus. The event bus delivers the change event to anyone who's interested in the application. That includes the presenter who originally initiated the change. It also includes other parts of the application that may be interested. This employee record that I've just changed, it may be displayed in many places on the application. Maybe the title on the web page is actually the employee name for the current record. Maybe the details screen shows the employee name. Maybe the summary also shows the employee name. So that's 3 places that need to be updated. Those 3 places can all register with the event bus to be notified of any changes. Now, we've had automatic code generation for the DTO side. That's great. But you might be saying, the presenter is also too much work. I don't want to write so much code. So we want to help you there. We're introducing a new concept called activity. We've kind of borrowed this concept from other engineers at Google who are used to building applications. It's a little bit related to Android activities, but in the details, it's actually very different, so don't think about that too much. Activities are these isolated things that happen in your application. For example, I want to edit an employee. That might be an activity. I want to display a list of results. That might be another activity. So let's see how this works. We still have the event bus, but we have this new thing called the activity manager. It is kind of the orchestrator. It's the thing that can take a new activity and shut down an old activity and put it in place. So what happens? Let's say the user clicks on an edit button to edit an employee record. The activity manager will first call the onStop method on the existing activity. The existing activity, which was something else in the application, now has an opportunity to clean itself up, to shut itself down, maybe to display a notification dialog that says, "You're about to lose some data. Are you sure?" Once that call returns, the activity manager can call the start method of the new activity. That new activity will make a request asynchronously via the request factory for anything it needs. Let's say I clicked on employee number 5, the edit button. I have to go to the server and get all the details for employee number 5 so I can display them in the edit user interface. So that request is made to the server, the result comes back asynchronously, and then the activity has the data it needs. At that point, the activity can display itself, draw the widgets, and show the edit user interface for employee number 5. So how does this look in testing? Well, we can create a mock activity manager. That's a fake activity manager. And we can use the activity that's automatically generated. And we can create a mock request factory, or a fake request factory. Now, we can test our activity and any changes we've made to it. Because these activities are quite isolated. These activities don't talk to other activities. They're independent. It's quite easy to set up a little test application with just one activity. You can create a test app that is edit user number 5. And every time you run that app, the app installs the edit activity, it fetches employee number 5 and displays it, and you can test the results. It's also easy to take this and turn it into a JUnit test. That makes your code very testable. Because of this isolation, when I'm as a developer changing this activity, or making code changes, my colleague is working on a different activity, and we don't step on each other's toes. We don't interfere with each other's code. Let's take a look at crawlability. So activity lifecycle should be very much tied to the bookmark history. So when I go from viewing 10 employees to editing employee number 5, I want the URL to change. I want the part after the hash fragment to change. Now, that might look something like this. Pound report colon 1, 2, 3, 4, 5, 6. That's the hash fragment to go to the screen that is the report with ID 1, 2, 3, 4, 5, 6. We have at the bottom here a URL, which is a new proposal for making AJAX applications crawlable by search engines. All you do is you add an exclamation point after the hash fragment, and there's also a meta tag that you use and some work that you do server-side. But this hash fragment with the exclamation point at the beginning is a hint to the Googlebot that your Ajax site is in fact crawlable, that the search engine can crawl through the different pages and transitions of your JavaScript website and still store those results in the search engine. There's a lot more details to it, so I encourage you to look at this URL so that you can make sure that your site is also crawlable. So, too boring to test is really too boring to write. When we say too boring to test, that's because in the model view presenter pattern, we've made the DTOs extremely easy. They're very simple containers. There's no events. They're just a bag of properties. We've made the view very simple, and we only tested maybe once initially, and we use widgets that are well tested. The activity, that's where we do some of our customization. But we'd like to do more with the view. What can we do to increase the code generation there? Because there's a lot of sort of data binding happening. When you have the DTO with your employee properties, and you have the widget with all the text fields and buttons, every time you have a DTO and you have to translate it to a widget, you have to do repetition. You have to say employee.getFirstName. And you have to take that value and you have to put it in a text field. Text field.setValue, employee.getName. If you have many fields, this gets very boring to write. You have all these properties that you have to copy from the DTO to the widget, to the view. And of course, as soon as someone clicks save, you have to copy all those same properties from the view back into the DTO. That's what we call too boring to test and too boring to write. So we're introducing a new class, a new interface called editor support. This is to help you get rid of some of that boilerplate and focus on the valuable pieces. So I just have one code snippet to share with you today. And this just gives you an idea of what editor support might look like and how it might work. You see here that there's two fields. There's a display name and a username field. Now I could have 2 fields, or 5 fields, or 10 fields. What editor support does is it takes care of all the copy code. Copy these 5 fields to these 5 fields. Copy these 10 fields to these 10 fields. So there's a little bit of boilerplate here, but it's the same for every class. And now, if I want to add a first name property, I can just add one line of code for the first name property. Then in my widget, I add one text box, one label, and I'm done. And the editor support will take care of marshalling all the fields from one class of objects to the other. So we kept most of our promises. We talked about all of the subjects, really except for one, which was lots of users, scalability. Now we have a scalable hosting platform that you may have heard of called Google App Engine. But there's some choices and trade-offs for you to make. In everything that we discussed here, we're using JPA for persistence. And you have to make the choice between relational and the conveniences of relational databases versus the convenience of scalability and not having to worry about the number of servers. So you can choose to store your data in an SQL database and get all the relational features without the super scalability. Or you can store it in a non-relational environment like the Google App Engine data store and get all the scalability without the relationships. So that was the biggest part of the talk, isolation. I want to briefly go into instrumentation. What does that mean, instrumentation? It's really about keeping your eyes on what the user is doing, what all of your users are doing. And you have many, many users, hopefully. So there are a few things that we mean by this. Logging, capturing stack traces for when there's problems, and something new that we're calling user actions. So logging is about taking things that happen on the client side and capturing those in messages that you ship to the server so that you as a developer can see those messages. Today there's kind of two popular choices for logging in GWT. There's a project that I maintain called GWT Log, and it's been available for a number of releases. It's a project that I started many years before I joined Google, right when GWT was launched, and it's a project I continue to maintain in my 20% time. Very recently, though, we were able to introduce logging into GWT proper, and we have been able to emulate the Java util logging API. This is starting in GWT 2.1. So you can use standard Java util logging and have your messages be captured on the client and then shipped to the server. One of the things that you can do is let the logs piggyback on top of existing requests. So you capture the logs locally, and then the next time you make a request to the server to fetch an employee or to update some data, you just take the log records and you add them to the request. And they kind of ship almost for free to the server. One of the trade-offs that you have to make is if you only piggyback the logging requests on existing requests, you may miss some information. If a user clicks in your user interface and does some things, but generates no requests, then those log messages are trapped on the client. So a good practice is to have a timer that maybe every 30 seconds fires, and when that timer fires, if you have any logging requests left on the client, then you ship them to the server by themselves. And you can play with the time. You can do more often, less often. It's a trade-off of how much data you can capture. Stack traces is about capturing things that go wrong on the client. Now we all know with GWT that when you do development in Java, you have Java stack traces. You can read them, you can click on them, you know what class, what method, what line number failed. But when GWT compiles your application, it obfuscates the code. And when you get a stack trace of obfuscated code, it's very hard to read and very hard to figure out what went wrong. It's also true that some web browsers don't provide stack traces in JavaScript. That's very unfortunate. So on the GWT team, we decided that we would kind of help you with that. I'm going to jump forward one slide. We're going to, we provided emulated stack traces. So for browsers that don't support it, we can add stack trace information to your application. It adds some overhead to the compiled output, but it means that you have a lot more detailed information about those stack traces. If this overhead is too much for all of your users, you can compile two versions of your applications. One with stack traces enabled and emulated, one with them disabled. And then you can say, I'll take 1% of user traffic, and I will give them a version of the app with stack traces. So that if a problem occurs, that 1% of users can still report those error messages back to you. Now, if you have these stack traces, you need to get them to the server. There's a couple ways to do that. Since a few releases, there's something called HTTP Throwable Reporter. This is a class you can find and it simply takes your stack trace and ships it to the server as JSON, and then you worry about it there. The other way is to use GWT log or Java util logging and ship them to the server that way. In both cases, you'll receive on the server obfuscated stack traces, which you need to re-symbolize. You need to add the original symbols back so that instead of obfuscated JavaScript, you have readable Java method names. And we've documented how to do that here below, although it's a little bit cryptic, so it may involve some work. And we're planning on making that better and easier and automatic for you. So emulated stack traces in production. This is an example of how you would do this with GWT log. You inherit the GWT log module. In this case, we've selected the off level. So logging is turned off by default in production. I'm also going to compile the same application again with info turned on. That means any log messages, info or higher, will be logged, but debug and lower will not. Anything that's debug or lower is removed from your code during the compilation process. Now, your users by default will have logging turned off, so they won't pay the penalty. But if you want to debug something, you can provide them a special URL with the log level parameter, and they will get a different version of your application with the logging statements. You can do this with any level: debug, warn, error, etc. So now user actions. These are something new that we're working on. User actions are kind of like unique strings that identify specific activities within your application. They can be very granular. They can be associated with a particular widget or a particular feature. They can be on a link or a button. You might be able to embed them in your UI binder XML file. And what you can do is you can note the timestamp of when a user clicks on this and then when the responses come back. So what happens is you click on, say, the Edit Employee button, and the framework will capture the timestamp, will send off the asynchronous request to the server, and maybe there's 3 or 4 requests that happen. Those requests all come back, and when the last request comes in, we again note the timestamp. And that difference, time, can be sent to the server and tracked and charted. So now you can monitor the performance of your application in a very granular way. You can also monitor which features, which user actions your users are actually using. Which features do they click on? Which features are slow? Which features are slower this week than they were last week because I implemented a code change that made something slower? And this is planned for the final release of GWT 2.1. So one more topic was suspicion. And really, this is about protecting your users. We want to guard against cross-site scripting attacks. And we recently discovered that we kind of have one extra way of doing this for free. In GWT 2.1, there is a new HTTP header which is automatically set by the GWT RPC mechanism. This header is called XGWT permutation. And it's used to pass the permutation name of the current code being executed to the server, because that's useful to the server. But it has this nice side effect, because only XHR requests can set headers. Regular URL references, inline images, can't set this header. So by making an extra check on the server to look for this special header, you can know that XHR request was responsible. Furthermore, XHR is limited to requests from the same domain. So this indirectly enables some protection because only code from the same domain can make this type of request. Of course, this is not enough to be safe. I think with Flash you might be able to get around this. Certainly any custom client code could be written. So this is one more step of protection, but it's not enough. You always need multiple layers of security. Another area of attack is HTML injection. This is when you have a place in your application where a user can enter some text, some information, and then you take that text and you store it, and later you render it back to the user in HTML. So you might ask a user for the employee name, and maybe the hacker, a regular user might type Fred as the employee name. A hacker might have a very special employee name. Open bracket, script, source equals hacker.com/evil, close bracket. And if you render that back to the user, then the hacker has a way of injecting JavaScript into your website, getting control of your data. So it's very important that you filter any user input and make sure that you only render it back in a safe way. So the Wave team open sourced some of the safe HTML features ahead of the plans. We always wanted to do it through GWT or other mechanism. And so we're going to put this ultimately into GWT, but until then, you can find it and use it in your own projects directly. So how does this work? You have, really you replace set inner text, set HTML is not safe if the user supplied the HTML. Also, set inner HTML is not safe. You can do set text and set inner text, but that removes any capability for formatting. So another approach is to use safe HTML to sanitize or clean up the HTML and remove any dangerous things like script tags. This is a very complicated problem with a lot of edge cases. And so it's important to have a well-tested framework that people can vet for any problems. And this, what we hope safe HTML should be. So, to kind of recap, production ready means a number of things. But ultimately it's to be isolated, isolate different pieces of your code, be instrumented, understand what your users are doing, what features they're using, and what performance they're seeing, and be suspicious. Any traffic that comes in, any user input that comes to your application, treat it as suspect, because you want to protect your users. Also, don't work so hard in creating all the boilerplate. Use this pattern, but use generated code. Generated DTOs, activities created for you, and the new editor support. And finally, please come to the office hours in 20 minutes and ask me all your personal questions that you don't have a chance to ask now. But before we do that, I think we have 5 minutes for questions. I'm sorry there's no translation, so if you don't mind, English only, and I will repeat the questions. Thank you very much. Any questions? Please raise your hand. No? Oh, yes. Thank you. Yes.
When a view contains another widget that I want to make it as a MVP pattern, what can we do? I mean, the view is hierarchical.
Okay. So if the view is hierarchical, how can I use the MVP pattern? That's a good question. It's complicated. What you can do is you can build composite views. So out of a few basic widgets, you can create a bigger widget. You can also use a application controller to orchestrate multiple presenters. Ultimately, it's a choice that you have to make for each application. MVP is kind of a guideline and a starting point. But each product that you build and each product that we have at Google is built a little bit differently, and they have different needs. Some can use more code generation, others less. MVP is implemented a little differently. The presenters, the activities, these are all things that are different. And what we're trying to do in GWT 2.1 and later is provide the best guidelines for getting started for most common applications. But it's always just a start. Each application is unique, and you need to do some unique problem solving. So it's ultimately engineering, software development. It's tricky. Thank you. Any more questions? Okay, thank you. Please come to office hours, ask your questions.